Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P16BB, indicates a low voltage issue in the Alternator B terminal circuit. This code is applicable to the Honda CR-V models from 2023 onwards. When the Powertrain Control Module, PCM, detects that the voltage supply from the alternator is outside the permissible range, it triggers this code and stores it for further diagnosis. The primary role of the alternator is to generate electricity to charge the battery and power electrical systems while the engine runs. The B terminal of the alternator is crucial in facilitating this electrical transfer. Thus, issues in this circuit can lead to various electrical malfunctions. It is vital to accurately diagnose the root cause of this low voltage condition before taking any corrective actions. The DTC P16BB signifies a low voltage issue specifically in the Alternator B terminal circuit. The impact of this malfunction is significant as it affects the normal operations of the PCM, which relies on proper voltage levels for appropriate functioning. The alternator, located typically near the front of the engine bay, it generates electrical power for the vehicle's systems. By producing electricity, it ensures the battery remains charged while the vehicle is in operation. When the voltage at the B terminal is lower than expected, the PCM interprets this as an abnormality that needs attention. Any irregularity at this point can disrupt the overall functionality of the electrical systems in the vehicle. Several potential causes can lead to the DTC P16BB being triggered. A faulty alternator is a primary suspect, as it may not be able to generate the required voltage due to internal failures. Additionally, damaged wiring or connectors in the Alternator B circuit can result in poor electrical connectivity, leading to a drop in voltage. It is essential to check these components closely, as the integrity of electrical connections directly affects performance. A blown fuse related to the alternator could also cause this issue by severing electrical flow. Each of these factors should be investigated thoroughly to determine the root cause of the low voltage condition. When dealing with the DTC P16BB, several symptoms may manifest that indicate an underlying problem. Dimming of the vehicle's lights, both exterior and dashboard, typically signals inadequate power supply. The battery warning light may illuminate on the dashboard, suggesting that the battery is not being charged sufficiently. Additionally, various electrical system malfunctions can occur, as a low voltage supply can impact the functioning of power windows, locks, and other accessories. These symptoms are critical indicators that should prompt immediate diagnosis to avoid further complications and ensure the vehicle operates optimally. For the first troubleshooting step regarding DTC P16BB, start the engine and ensure that several conditions are met for effective diagnostic evaluation. Set the air conditioning, AC, to the maximum cooling setting, which activates the system's highest demand for electrical power. Additionally, the blower fan should be set to its maximum speed to increase power consumption further. Simultaneously, turn on the headlights to the high beam setting, which will pull additional power from the alternator. This combination of settings simulates a high electrical load on the system. Maintain the engine speed at 2,000 revolutions per minute, RPM, without load, ensuring the vehicle is in park or neutral for 1 minute to observe how the alternator performs under these conditions. The second troubleshooting step involves a detailed inspection of the ACG plus B circuit. Start by examining the ACG plus B wiring for any visible signs of damage or wear that might interrupt electrical flow. Following this, it's crucial to check the condition of the Alternator B terminal itself, as loose connections or corrosion can lead to poor connectivity. Concurrently, inspect all related circuit terminals, ensuring they are clean and secure. Each of these areas must be verified to confirm they're functioning properly and not contributing to the low voltage issue. If abnormalities are discovered during these inspections, further inspections may be warranted to pinpoint the exact failure. During the third troubleshooting step, closely examine the connection conditions at various points, particularly around the Alternator B terminal and the alternator itself. Loose or corroded connections can significantly impede electrical flow, leading to low voltage readings. Additionally, inspect the fuse holder A that is associated with the ACG_B line for any signs of damage or a blown fuse, as this could be a simple cause of the problem. It is also essential to analyze the wiring integrity running to these components. Cracked insulation or exposed wires could create faults within the circuit. These tasks will help identify whether the issue lies within the connection points or in the underlying wiring itself. The final troubleshooting procedure focuses on a comprehensive inspection of the alternator. If previous checks have confirmed the connection points and wiring are intact, the next logical step is to assess the condition of the alternator itself. Start by evaluating its output under load conditions to confirm whether it meets the necessary specifications. If the alternator fails to produce adequate voltage or exhibits erratic readings, it likely has internal faults that need addressing. Symptoms such as unusual noises or overheating during operation can also provide clues regarding its health. Determining that the alternator is faulty as the remaining cause means it will require replacement to rectify the low voltage issue and restore proper functioning. After completing the necessary repairs, it is essential to conduct a final verification of the alternator's functionality. Begin by testing the output again to ensure that it is generating the required voltage levels. Once the repairs are verified, clear the stored DTC from the PCM, which resets the monitoring system. Following this, monitor the vehicle systems under various conditions to ensure everything operates smoothly and that the DTC does not reappear. This final step is crucial for ensuring that all associated components are functioning correctly and that the previous issues have been resolved completely. Conclusively, if all systems operate normally without triggering the DTC again, the repair can be considered successful. To prevent future occurrences of DTC P16BB, a proactive maintenance routine is essential. Regular inspections of the alternator should be incorporated into standard vehicle maintenance schedules, ensuring that all components are functioning within required specifications. Additionally, routinely check the wiring connections to the alternator and related circuits for signs of wear, corrosion, or loose connections. Monitoring the electrical system's overall health can help detect early warning signs of potential issues, allowing for timely preventative measures to be enacted. Small maintenance actions, such as cleaning terminals and replacing worn wires, can greatly enhance the longevity of the vehicle's electrical system and overall reliability. In summary, the DTC P16BB indicates a critical issue with low voltage in the Alternator B terminal circuit. Understanding its significance is crucial for effective troubleshooting and rectification. Following a structured troubleshooting approach is vital to identify the source of the problem accurately, be it the alternator, wiring, or connections. Each aspect must be thoroughly examined to ensure no area is overlooked. Furthermore, the importance of preventive maintenance cannot be understated in preserving the functionality of the vehicle's electrical system. By taking a proactive approach and regularly inspecting components, you can minimize the risk of recurrence for this issue and enhance overall vehicle performance. Please like and subscribe to the channel See you next time.